All right, so in addition to converting all of your pressures to match, you also need to convert all of your temperatures to a scale called Kelvin. Um, and Kelvin is spelled K-A-L-V-E-N? No, Kelvin. K-E-V-I-N. I don't know. You guys all know spelling is not my forte, but I can tell you the history of it. So Fahrenheit, is only used in the United States. Celsius is used worldwide and in science. But scientists needed a positive only temperature. So they developed Kelvin. And they have yet to get to a negative temperature for Kelvin. I think they recorded 0.000560, something like that, 1 degree, but they have not reached absolute zero yet for Kelvin. And so this is why the temperature scale was created, because if you are factoring temperature with pressure, and you have like a negative temperature, let's say, negative 10 degrees Fahrenheit, or like 0 degrees Celsius, it's going to make your pressure 0 degrees Celsius. So they had to come up with a temperature that wasn't negative or zero, because you couldn't really have a negative or zero pressure. You could have a negative change in pressure, like starting at a higher pressure and reducing to a lower pressure, but you didn't want to have like a zero pressure when you have a zero temperature, because that's not necessarily the case. So, anyways, they came up with this Kelvin temperature, one that I don't know how to spell. I will look it up though. And so all of your temperatures will usually be given to you in degrees Celsius. So it's a pretty standard equation. It's right here. You just take your degrees Celsius and you add 273. So whatever your degrees Celsius is in, no matter what the number is, if it's negative or positive or zero, you would just add 273. So let's say we have negative 10 degrees Celsius, super cold. Give me a second, I wrote my C, degrees Celsius plus 273, and your answer would be 263 Kelvin. So pretty straightforward, probably the easiest conversion you're going to do all year. I hope you like this one. If you have, let's say, 40 degrees Celsius, you add 273, and you end up with 273 plus 40, 313. Sorry, I can't do math in my head. I wish I could. Practice that mental math so you don't look stupid when you're my age. And so it's just a pretty easy conversion, but everything has to be in Kelvin. That's the main thing. You need to know that all your temperatures have to be in Kelvin. Okay? So hopefully you enjoyed this little handy dandy clip, and just make sure that whenever you're factoring in any temperature for any of these formulas that we have. So when you're using Charles's law and you have this temperature right here and this temperature right here, or Gay-Lussac's temperature, you have it in Kelvin. Combined gas law is also in Kelvin. And then your ideal gas law, PV equals nRT, your temperature has to be in Kelvin to factor out this gas law's constant, because both gas laws constant have Kelvin as your temperature. So there you go. Enjoy.